Okay guys, so we're going to try something here. I'm going to try to do a lecture. It's probably going to come in a couple of parts. I've oriented the camera just a little bit here so you can just kind of barely see. I've got my tablet here. I'm going to post these slides. These are my normal PowerPoint slides I would do in class. I've got my paper here to act as the whiteboard. Let's give this a try. I don't know how this is going to work, but we'll give this a try, okay? So, this would be after exam 2. We would start up talking about the being able to describe the effects of viscosity, right? So, what we will try to do in this section, where this is exam 3 topics, we talk about viscosity and viscous flow. Let's talk about viscous flow. Okay. Now, viscous flow can take a couple of forms here, right? And so we talk about. Previously we've talked about the energy equation. And we've seen many forms, and we've seen the power form of that. We've seen the energy per unit mass form, the pressure form, etc. Okay. Now, in all of those forms, with the exception of the Bernoulli equation, because it's derived using the assumption that there's no external energy and there's no energy loss, in all the other forms, all the general energy equation as applied to fluids, conservation of energy forms, we see this loss term. And there's this loss term. And describing that loss term, how do we quantify that? You know, up to this point, it's been something we either assume is negligible, or it's something that is given to us, or it's what we're actually trying to solve for, right? Well, in our text, when we hit chapter 8, that changes. Now we're going to talk about different ways that we can try to quantify that loss term. How can we find it? And then in chapter 11, we're going to look at some other ways to look at the effects of viscous flow. But for chapter 8, we're going to focus with modeling or trying to describe that loss term. And chapter 13, honestly, a little bit later, too, if we have time. Now, to be able to describe the loss term, we need to know what kind of flow are we dealing with. So there's different categories. The two main categories, of course, would be external flow or internal flow. So external flow, that's where we're looking at so the different models for describing viscous flow. And by the way, I'm drawing stuff here. I assume you're going to want to take notes too. Have you some paper out and a pencil or pen, and pause this video long enough to get that stuff out if you're not already prepared. But I'm trying to do this like I would normally do in class, so you have an opportunity to kind of do the same thing you would normally do in class. Take some notes here. So viscous flow, this would be, again, it can come in two forms, as we're saying here. One of those is external flow. And that's things like lift and drag, which we will talk about. For us, we talk about these in chapter 11. And so that'll be kind of the second half of this exam 2 material. Right, so in the Changle and Symbolic text, this is chapter 11. We talk about viscous flow on external surfaces or external bodies. Now, first, though, we're going to focus on chapter 8. That's where we talk about internal flow. Right? And internal flow can come in a couple of forms. In chapter 8, we're going to focus on the completely filled conduit. And then a little bit later, if we get time, we can talk about open channel or not completely filled. But if we talk about internal flow, as this is external flow, This is internal flow. So external flow is when you've got the fluid flowing over an object, right? External flow is when you have fluid flowing through a conduit, a pipe, or a duct. We'll talk a little about those in a second. It can take a couple of forms, as we're mentioning here. It can come in the form of completely filled conduit. For us, that's Chapter 8. It can also take the form of what we call open channel flow, which is where you've got a conduit that is not completely filled. And so the rules are a little bit different, and the models end up being a little bit different for that. For us, that's going to be Chapter 13. Again, if we have time, we'll look at that a little bit later. Okay? Let's see how the rest of the semester goes. So that's what we're looking at there. Now, so as I said, in this chapter, we're going to focus on internal flow in completely filled conduits. Now, let's talk about a couple of types of conduits we might see. Now, I just kind of pulled some images here from Google or somewhere like that, and I haven't referenced my images here. They're some kind of free source. Pipes versus ducts, and which is which. And the truth is, I don't know how much it matters. For our purposes in this class, it really doesn't matter whether it's a pipe or if it's a duct. And so we talk about pipe versus a duct. How much does it really matter? Well, they're both conduits. Right? For our purposes, and really what this all boils down to is estimating loss. And it works the same. So again, how much do we care? I don't know. It's kind of a technical difference. Normally pipes are circular. Right? So normally for pipes, the pressure is normally greater than an atmosphere. For that reason, they've got to be circular, typically. I'm just barely on the screen there, aren't I? Let's move up just a little bit. So for our purposes, again, it's not really too big a difference. Pipes need to be circular because typically the pressure is going to be greater than an atmosphere. So if I'm looking down a pipe here and notice that the pressure is pointing out in all directions, and if I have high pressure, a lot of pressure inside, and it's pointing out in all directions, as opposed to another shape conduit where maybe I've got pressure pushing here and pushing here and pushing here, you know, some sort of a square conduit, right? So again, pressure is going to push normal on all surfaces. Well, notice what happens here in the corners. You've got a bending moment caused right there in that corner because you've got some force pushing one way, you've got another force pushing another way, you get bending moments, and if this pressure is large, you're going to get, and I don't think I'm drawing that, well, I don't know if there's a good way to draw that. Anyway, basically you've got a stress point. You get a concentration of stress occurs right there in the sharp edges. So normally we would say a duct is any conduit where the pressure is less than an atmosphere, or not less than an atmosphere, approximately an atmosphere. Pressure approximately 1 atmosphere. Right. That's normally what we have for ducts. Again, do we care? No, not really. It's a technical term. For us, the estimating the loss works the same for both, in both cases. Okay, so let's see if I can reposition here and get this right. Get to learn all these new skills. Okay, let me check my alignment here. That's not too bad. I'm hoping this is helpful. I really do. I'm going to post these PowerPoint slides for you. They're in Canvas, so you can access them. There's some links in there. But I'm hoping this works a little bit for you. Okay. Now, so pipes versus ducts. Do we care? No, not really. What we really need to know more about is the flow laminar or is the flow turbulent? Now, again, when you get time, go look at these slides, and I've got some different videos here. Go watch these, and one of these I think is a Smarter Everyday video, and it might be this guy. I don't know if we can. Is I gonna watch this thing blow up on me here? Yes, it's a really good Smarter Everyday video.
Welcome back to Smarter Everyday.
So I'm not gonna make a YouTube video of you watch so you can watch another YouTube video. Go look at Smarter Everyday, and he does a really good description about the difference between laminar and turbulent flow. Okay, but I've got some other videos here that show pretty good information. You can find all kinds of information. You're going to find better videos out there than I can try to generate for you. It's already done, so go look at the difference between laminar and turbulent flow. Okay. In fact, if you need to pause this video and come back, that's fine. But here's the thing. So if we're talking about these completely filled conduits, and again, what are we trying to do? Well, we're trying to estimate the loss, the energy loss associated with fluid flow, specifically through completely filled conduits. Is it a pipe or a duct? It doesn't matter for our purposes. We're going to approach it the same way. But what we do need to know is it laminar? Is the flow laminar, or is the flow turbulent? That's what's important. All right, that's what we need to know. And again, go watch these videos so you know a little more about what those differences are. I'm going to check my time. This might be a good place. This is actually a very good place for me to break. So go look at those videos that I've posted. Go watch Smarter Every Day, at least the first 20 minutes of him talking about laminar versus turbulent flow, what they are, and then come back. And we'll pick up right here. We're going to talk about how do we estimate the loss for these different flow quantities. Okay? See you back in a second.